Assalamualaikum to Dr. Ashkin. Today I will presentation my proposal misconception in ruler measurement. And good morning and very good day to Doctor. My name is Muhammad Shahir bin Zawawi and today I will be presenting my research proposal entitled Addressing Pupils' Misconceptions in Ruler Measurement Using Disconfirming Evidence and Structural Alignment. The purpose of this study is to explore how primary school pupils understand measurement, particularly when using a ruler, and how different teaching strategies can improve their conceptual understanding. In this presentation, I will cover three main chapters. Chapter 1, Introduction, Chapter 2, Literature Review, and Chapter 3, Methodology. Okay, to the first, chapter 1, it is introduction. So, 1.1 background of the study. First, let us look at the background of the study. Mathematics is a fundamental subject in primary education because it helps pupils develop essential skills such as logical thinking, problem solving, and reasoning. These skills are not only important in school but also in everyday life. One of the key topics in primary mathematics is measurement, particularly measuring length using a ruler. This conception is widely used in real-life situations, such as measuring objects, estimating distances, and solving practical problems. However, despite its importance, many pupils struggle to understand the concept of measurement. Instead of developing a deep understanding, pupils often rely on memorized procedure. For example, they may simply read the number and at the end of an object and a ruler without understanding how measurement actually works. According to research by Known 2004, many pupils do not understand the measurement involves counting equal, interval, or unit. Instead, they are focused only on the number displayed on the ruler. This shows that people may appear to perform well, but in reality, they lack conceptual understanding. Okay, we go to the problem statement. Based on the issues, several problems can be identified. Firstly, pupils have misconception in ruler measurement. For example, they use incorrect strategies such as the read-off strategy, where they simply state the number at the endpoint, and hash mark counting, where they count the markings instead of the interval. These strategies are incorrect because they do not reflect the true concept of measurement. However, the problem becomes more serious because this misconception often go unnoticed. This is because in most classroom activities, objects are aligned with the 0 point on the ruler. As a result, pupils can still get correct answer even when using incorrect reasoning. Secondly, current teaching practices focus too much on procedural learning. Teachers usually show pupils how to use a ruler step by step, but they do not emphasize why the method works. As a result, pupils are unable to apply their knowledge in non-routine situations, such as when objects do not start at 0. Therefore, there is a need to address this misconception and introduce more effective teaching strategies. Okay, next we go to the purpose of the study. The purpose of the study is to investigate pupils' misconception in ruler measurement and to examine the effectiveness of two instructional strategies. First, disconfirming evidence, and two, structural alignment. In addition, this study aims to determine whether combining these two strategies that produce better learning outcomes compared to using each strategy individually. Okay, next, research objective and questions. The main objective of this study to identify the common misconception among pupils, and two, to examine the strategies used by pupils in measurement tasks, and three, to evaluate the effectiveness of DE and SA. Based on this objective, the study seeks to answer the following questions. The question, what misconception do pupils have in ruler measurement? Question 2, what strategies do they use to solve measurement problems? And question 3, which instructional strategies is more effective in improving conceptual understanding? Okay, next we go to the research hypothesis. This study proposed that this confirming evidence will improve pupils' understanding, and two, structural alignment will further enhance understanding. The combination of the confirming alignment, DE and SA, will produce the most significant improvement. So next, significance of the study. This study is important for several reasons. For teacher, it provides insight into pupils' misconception and suggests more effective teaching strategies. And for pupils, it helps them develop a deeper and more meaningful understanding of mathematical concepts. For the education system, it contributes to improving teaching practices and promoting conceptual learning in mathematics. So next, go to the limitation. However, this study has some limitation. It focuses only on a small sample of pupils, and the findings may not represent all schools. It also focuses only on ruler measurement and does not cover other topics. In addition, the study is conducted over a short period of time. Okay, we go to the summary of chapter 1, that is introduction. So in summary, chapter 1 explains the importance of measurement, the issue of misconception, and the need for effective teaching strategies to improve pupils' understanding about the topics. Okay, so we go to the literature review, that's chapter 2. So we go to the 2.1, the introduction. This chapter reviews previous studies related to misconception in measurement and effective teaching strategies. The purpose is to provide a theoretical foundation for the study. 2.2 is misconception in measurement. Research shows that misconceptions are common in mathematics learning. In ruler measurement, pupils often misunderstand the concept of unit. They may focus on number rather than interval. Found the pupils often perform well in simple tasks but fail in more complex situations, indicating a lack of conceptual understanding. Other studies also emphasize that misconception can hinder learning and must be addressed early. Okay, so I will explanation about this confirming evidence. So this confirming evidence is a teaching strategy that challenges pupils' incorrect beliefs. It works by presenting tasks that reveal errors in pupils' thinking. For example, when pupils measure objects that do not start at zero, they realize that their previous strategy is incorrect. This creates cognitive conflict, which encourages them to rethink their understanding. Next, I will explain about structural alignment. So, structural alignment helps pupils connect abstract concept with concrete representation. For example, using unit chips aligned with a ruler allows pupils to see that measurement involves counting equal spaces. This approach makes abstract concept easier to understanding to pupils. So, I will tell about combination of DE and SA. So research shows that combining DE and SA is more effective than using either strategy alone. DE helps change pupils' thinking, while SA helps them understand the correct concept. Together, they provide a more complete learning experience. So for the last of the summary of chapter 2, so in conclusion, in chapter 2, previous study highlight the importance of addressing misconception and using effective teaching strategies to improve conceptual understanding to the pupils. So we go to the last chapter is methodology. So last chapter is chapter 3 methodology. First, research design. In this study, a quasi-experimental research design is employed to examine the effectiveness of different instructional strategies in improving pupils' conceptual understanding of ruler measurement. A quasi-experimental design is chosen because it allows the researcher to compare groups in a real classroom setting where random assignment is not feasible. This design is commonly used in educational research as it provides a balance between control and practicality. The study adopts a pre-test and post-test non-equivalent control group design which involves 3 groups of pupils. The first experimental group receives instruction using disconfirming evidence. The second experimental group receives instruction using a combination of disconfirming evidence and structural alignment. And the third group, the control group, receives traditional instruction, often referred to as business as usually. The pretest is administered before the intervention to assess pupils' initial understanding of ruler measurement. This ensures that any differences in learning outcome can be compared accurately after the instructional intervention. A post-test is conducted to measure any improvement in pupils' conceptual understanding. This design allows the researcher to determine whether the instructional strategies are effective, and second, which strategy produce the greatest improvement. The inclusion of a control group is important as it provides a baseline for comparison, ensuring that any observed change are due to the intervention rather than internal factor. So in the chapter 3, we go to the population and sample. The population of this study consists of primary schools pupils in year 3 to year 4, typically aged between 8 to 10 years. This group is selected because they are at the stage where they are formally introduced to measurement concepts in the mathematics curriculum. At this level, pupils are expected not only to perform measurement tasks, but also to understand the underlying concept of measurement as counting equal units. Therefore, they are an appropriate group for investigating misconception in ruler measurement. The sample for this study is selected using a purposive sampling technique. This means that participants are chosen based on specific characteristics relevant to the study, such as having prior exposure to ruler measurement. A total of 75 pupils will be involved in this study, divided into 3 intake classes. 25 pupils in experimental group 1, 25 pupils in experimental group 2, and 25 pupils in the control group. So the use of intake classes ensure minimal disruption to the school's existing structure and maintain the natural classroom environment. So, to ensure fairness and comparability, the pupils' initial understanding will be assessed using the pretest. This helps confirm that the groups are relatively similar before the intervention begins. In addition, ethical considerations are taken into account, including obtain permission from the school, ensuring voluntary participation and maintaining confidentiality of pupils' data. Next, we go to the research instrument. The study would utilize carefully designed instrument to collect both quantitative and qualitative data. The primary instrument is the pretest and post-test, which are used to measure pupils' conceptual understanding of ruler measurement before and after the intervention. The test consists of structured items that assess different aspects of measurement, including tasks where object are aligned with the 0 point, 2 tasks where object do not start at 0, and 3 contextual problems involving real life. These items are specifically designed to identify common misconceptions, such as the tendency to read numbers directly from the ruler or to count markings incorrectly. Each response is evaluated based on conceptual accuracy rather than procedural correctness. This ensures that the test measure true understanding rather than memorization of steps. In addition to the test, an observation checklist is used during the intervention. The purpose of the observation is to record pupils' behavior, level of engagement, and the strategies they use when solve measurement tasks. This includes 1. Whether pupils can explain their reasoning. 2. Whether they correctly interpret measurement units. And 3. How they interact with instructional materials such as unit representation. The use of both tests and observation allows for a more comprehensive understanding of pupils' learning process. To ensure the quality of the instrument, they are reviewed by experienced educators for content validity. A pilot test is also conducted to ensure clarity and reliability. So we go to the data collection procedure. The data collection process is carried out in a structured and systematic manner to ensure consistency and accuracy. The first stage involves the administration of the pre-test. All pupils from the 3 groups are given the same test under similar conditions. The purpose of this stage is to determine their initial level of understanding and identify any existing misconception. The second stage involves the instructional intervention. Each group receives a different type of instruction. The first experimental group is exposed to this confirming evidence, where pupils are presented with tasks that challenge their existing understanding. These tasks are designed to create cognitive conflict, encouraging pupils to reconsider their thinking. The second experimental group receives a combination of this confirming evidence and structural alignment. In addition to experiencing cognitive conflict, pupils are provided with visual and concrete representation that help them understand the concept of measurement more clearly. The control group continues with traditional teaching method, focusing on procedural steps without additional conceptual support. During this stage, observation and conducted the monitor pupils' responses, engagement, and learning behavior. The final of the stage involves the administration of the post-test. This test is similar in structure to the pre-test and is used to measure any change in pupils. Understanding after the intervention, the comparison between pre-test and post-test result allows the researcher to evaluate the effectiveness of the instructional strategies. So, data analysis. The data collected from this study is analyzed using both quantitative and qualitative methods. For quantitative analysis, pupils score from the pre-test and post-test are examined using statistical techniques. Descriptive statistics use to summarize the data, including the mean and standard deviation for each group. This provides an overview of pupil performance. Inferential statistics are then applied to determine whether the differences observed are statistically significant. A pair sample t-test is used to compare pre-test and post-test scores within each group, allowing the researcher to determine whether there is improvement over time. One way, ANOVA is used to compare the performance between the three groups. This helps identify which instructional strategy is the most effective. If significant differences are found, further analysis is conducted to determine the specific differences between groups. For qualitative analysis, observation data is analyzed using the thematic approach. Patterns are identified based on pupils' behavior, reasoning, and engagement during the learning process. The findings from the qualitative analysis then use the spot and explain the quantitative result, providing a more complete understanding of the outcomes. So we go to the study implementation schedule. The implementation of the study is carefully planned to ensure that each phase is conducted systematically. The study is carried out in three main phases: preparation, intervention, and evaluation. During the preparation phase, all necessary arrangements are made, including obtaining permission, preparing instrument, and conducting pilot testing. The intervention phase involves administering the pre-test, conducting instructional sessions, and recording observation. And the evaluation phase includes administering the post-test, analyzing the data, and interpreting the results. This structured schedule ensure that the study is conducted efficiently while maintaining the reliability and validity of the findings. So, the conclusion of this chapter is this study highlights the importance of addressing conceptions in measurement by using strategies such as disconfirming evidence and structural alignment. Pupils can develop a deeper understanding of mathematical concepts. This study aims to contribute to more effective teaching practices in primary mathematics education. I think that's all from my presentation. That's all my presentation about my proposal. So thank you.